Okay, proof of the base angles theorem. Now, the base angles theorem is a proof about an isosceles triangle. So the statement that we have here is if AB is congruent to BC, then angle A is congruent to angle C. So I'm just going to mark this triangle with what the if statement is saying to us. So if you have one side here, AB, and that's congruent to the other side of the triangle BC, then angle A should be equal to angle C. Okay? And so this, this is somewhat intuitive. We look at a triangle, we say that these two sides are congruent, so these two angles should also be congruent. Okay? And common sense dictates that to us, and we want to say that it's true, but we can't say that definitively and for sure until we actually prove it. Okay? Now, what makes this proof a little bit different from other triangle proofs is that we're not proving two triangles are congruent. What we're really doing here is proving that two angles within the same triangle is congruent. Okay? And so the idea here is if we can somehow find a way to split this triangle into two other triangles, then we can complete this proof. Okay. So the first thing that I'm going to do is find the midpoint of AC, and I'm going to call this point D. Okay, so I'll write this down. Draw D as midpoint of AC. Now I know that I can do this because every single line segment is going to have a midpoint. In other words, for every single distance, there's a point in the middle there that's halfway. Okay? To actually show how to do this is a construction proof, and we'll have to do that later. But for now, we can say that every single line segment has a midpoint. So I'm just going to give that midpoint a name D. Okay? Then the next thing that I'm going to do is use this midpoint in order to split this triangle into two smaller triangles. So the next thing I can say is draw BD. And I'll put a little bit of a reason here, and my reason is really that 2 points determine a line. In other words, if I have 2 points anywhere, I can take my ruler and connect them together, and that gives me a line or a line segment. Okay. Another way to put this is basically using the ruler postulate, but I'll put this in a little bit more expanded form here. Okay. So now I have two different triangles, ABD and CBD. And remember, my goal is to somehow prove that A is congruent to C. In other words, angle A is congruent to angle C. So if I can show that ABD is congruent to CBD, triangle ABD and triangle CBD, then I can say that these two angles down here must also be congruent to each other. Okay? And that's sort of my strategy, the big idea that I'm using here. So I'm going to say, first with my statement and reason, I'm going to use a classic two-column proof here. Okay? So the first thing that I'm going to say is that AB is congruent to BC, and this is given. I say that it's given because it's part of the hypothesis, part of the premise of our if statement. Okay, so in any proof, if you have something that's written in the premise, we can use it as a given statement. So AB is congruent to BC, that's given. Okay. Then I can show that BD is congruent to DB, because it's really just the same segment, and this is reflexive. So I'm basically trying to prove that these two triangles are congruent by side, and here I have a side, here I have a side, and I only need one more side to somehow prove that these two triangles, ABD and CBD, are congruent. Okay? And this third side is going to come because I made D the midpoint. So I can put these two tick marks in there, and I can say that AD is congruent to CD because of the definition of a midpoint. And that effectively gives me the third side of the triangle. So now I can say that triangle ABD is congruent to triangle CBD using side, side, side. Now, since the two triangles are congruent, any of the corresponding parts of the triangle has to be congruent as well. In other words, angle A has to be congruent to angle C. Angle A is congruent to angle C, and this is corresponding parts of congruent triangles, or CPCT. I'm going to write it out once here, and then just use the abbreviation going forward in all of the other videos. And there you have it. If we know that you have an isosceles triangle with two sides congruent, then we can also know that the two angles down here, the base angles, are congruent to each other as well, using the logic and the proof that we have here.